Boloda Year 10. Today's lesson is on images of the universe. So you're going to need the assignment out ready to fill in questions as we go through the lesson. First of all, I want you to pause the video and have a go at the Do Now activity. So you need to label the diagram showing the order of planets from the Sun, and then as an extension question, if you're feeling confident, you need to write down which planets are the terrestrial planets and which are the gas planets. So pause the video now and have a go at the Do Now activity, and after you finish, come back ready to go through the rest of the lesson. Okay, so for labelling the diagram, you should have said that the first one is the Sun. And then, after the Sun, the closest planet is Mercury, followed by Venus, the Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then between Mars and Jupiter, we have our asteroid belt. Okay, so which planets are terrestrial planets and which are gas planets? For the terrestrial planets, you should have said that it's Mercury, Venus, Earth, and Mars. And for the gas planets, we have Jupiter, Saturn, Uranus, and Neptune. So the aim of our lesson is to understand how images of the universe are taken and the involvement of the EMS, or electromagnetic spectrum. So our key words are electromagnetic spectrum, telescope, and radiation. So we're going to start with a recap of the electromagnetic spectrum. So the electromagnetic spectrum, or EMS, is a group of waves that all travel at the speed of light. They have different wavelengths and frequencies and can be used for different things, for example, communication. So at the beginning of our electromagnetic spectrum, we have radio waves. These have a long wavelength, low frequency, and low energy. As you can see, as we go across the electromagnetic spectrum, the wavelength decreases and the frequency and energy increase. So after wavelengths, we have microwaves, followed by infrared, visible light, ultraviolet, X-rays, and gamma rays. Gamma rays have a very short wavelength, high frequencies, and high energies. You can see the changing in wavelengths from the wave line. So at the beginning, radio waves, you can see the waves are a lot more spread out, showing a long wavelength. But towards gamma rays, they're a lot closer together, showing a short wavelength and high frequency. So the EMS is a great tool for scientists looking into space. Different regions of the EMS have been used to photograph the space with interesting outcomes. We'll look at some images later. So the EMS allows us to look at long distances into the universe. We can see things that are not possible to see with the naked eye. Okay, so we're going to talk about telescopes. So as we've already mentioned, a lot of stars and galaxies are too far away for humans to reach. We can't just go and travel to see them and study them up close, so we need tools to allow us to study them from Earth. Because the scientists have gathered information they have from radiation, we know a lot about science. Okay, so scientists analyse the radiation produced to gather information on planets and the universe. Telescopes have been developed as a tool to help observe and study different planets, and over time there has been many new designs which have many advantages and allow us to see lots of things into space. Some are used on Earth, while others have been developed to be used in space. Okay, so we're going to talk about the optical telescope. This is probably the most common telescope, and it's the one that average astronomers can use from their houses at night. So these telescopes observe visible light from space. So they're part of the visible lights part of the electromagnetic spectrum. And as I've already mentioned, they can be used by regular people to stargaze at night. However, we also have bigger ones that are used professionally to help study space. Optical telescopes, however, can only be used at night, and the sky must be clear. There must be no cloud cover to be able to see our planets. So in times of bad weather or high cloud cover, we cannot use our optical telescopes. So we're now going to look at radio wave and X-ray telescopes. Radio wave telescopes use radio waves coming from space to produce images. Radio wave telescopes are expensive, however they do have an advantage. These can be used in different weather conditions and both day and night, because they can work through different weathers, and they're not stopped by clouds. X-ray telescopes produce X-ray images. However, these are partly blocked by the Earth's atmosphere, and therefore they need to be high up or flown in balloons to be able to use them. So can we use any other parts of the EMS or electromagnetic spectrum for space imaging? The answer is yes, definitely. So other parts of the EMS, like infrared radiation and gamma rays, can be used to image space. However, our Earth's atmosphere blocks them, and therefore the scientists need to design a way for putting them into space. They have designed telescopes that can be placed in orbit around the Earth, as we can see from the image. These are advantageous as they can observe the whole sky in day and night. However, they are very expensive and hard to both launch and maintain. For example, if something went wrong with the telescope, space people would need to go out to solve this. So we need to send our scientists into space to be able to solve the problems with these telescopes. This is expensive and obviously hard to do. An example of a space telescope is the Hubble Space Telescope. Okay, so you now need to pause the video and have a go at the review activity. So you need to complete the sentences. So the electromagnetic spectrum is useful in seeing far into the universe. Blank can be used from the Earth and from space to produce images. Scientists gather information on planets based on the blank released. And then you need to answer, what is the advantages and disadvantages for using telescopes situated in space? And what is the most common form of telescope and what part of the EMS does it use? So pause the video and have a go at these activities now. After you finish, come back to carry on with the lesson. Okay, so let's go through completing the sentences. The electromagnetic spectrum is useful in seeing far into the universe. Telescopes can be used from the Earth and from space to produce images. Scientists gather information on planets based on the radiation released. So what are the advantages and disadvantages for using telescopes situated in space? So for our advantages, you should have said they can be used in day and night and observe the whole sky. They can also use more of the electromagnetic spectrum to produce images. However, disadvantages are they're expensive to launch and maintain. What is the most common form of telescope and what part of the EMS does it use? For this, you should have said optical telescope, and it uses visible light. Okay, so now we're going to look at some type of images produced by different parts of the electromagnetic spectrum. So first of all, we have visible light images. So we can see here examples of visible light images of the Sun, the Earth, the Moon, and then the galaxy. Now we're going to look at X-ray and ultraviolet images. So the top two are X-ray images of the Sun. And then we have for the ultraviolet images of the Sun and also of the galaxy. You can already start to see the differences between images of the different parts of the electromagnetic spectrum. Here we have infrared images of the Sun, the Milky Way, and Jupiter. Again, showing lots of differences from both visible light images and ultraviolet. We now have microwave images. So this is of the Sun and CMBR. So our CMBR is a cosmic microwave background radiation. So as evidence of the Big Bang Theory, it was suggested that after the explosion that created the universe, microwave background radiation would be left over. This radiation was then discovered in 1964. This is known as the cosmic microwave background radiation. Okay, so we now have images of black holes. If you remember, back in 2019, NASA made a breakthrough inside of the science of space, and they were able to use a telescope to take an image of a black hole and its shadows, which you can see here. Okay, so we now have an activity for you to do. So on the assignment, you need to complete the table. This is a research task where you need to find different ESM images of the different parts of the space. For example, the Sun. So in this column, we have the types of ESM imaging. So visible light, radio waves, microwaves, ultraviolet, X-rays and infrared. And then I've given you different objects to research. So the moon, stars, sun, galaxy, sun again, and Jupiter. So what you need to do is go away and research different images for these. For example, I've done one for you. So infrared, you need to go and Google. I went and Googled an infrared imaging of Jupiter and inserted it in the image column. You need to do the same for all the others. After you've finished, make sure you complete all the different parts of the assignment and hand in the assignment. Well done for working hard on this lesson.